Hello everyone and welcome back to the Victoria Game Engine series. It is episode 11 and today we are going to be focusing on context creation for Linux. For those of you who are unaware as to what a context is, please go and refer to the Windows version of this video. That'll be the first few minutes of the video and then you can come back here. For those of you who did watch that video, we are just going to get straight into the creation of the GL Manager. Now, it should be noted that the implementation that we're doing today is only going to be working for the X11 windowing library. If you're using something such as Wayland, this will not work because the GLX library that we're going to be using for this only exists for X11 and it does not exist in the same capacity for Wayland, or at least not to my knowledge. With that out of the way, let's go under the Linux folder here and let's go and create a GL Manager X11.h as our header file. And of course, within this file, the first thing we're going to do is going to pragma once. We're going to include our type defs. We're going to check if we're using platform Linux. We're going to end that if. And then within here, we're going to want a couple of things. The first thing we're going to want is we're going to want to include core error macros, and we're going to want to include our third-party library. And below this, we're also going to want to include our X11 headers. So from X11-xlib-h. And we're also going to want to include gl-glx.h. And those should get us all of the things that we're going to need for this video. So the class is going to look something like this, and I'll just paste it in. And do remember here to cap it off at the end, like so that you don't get any errors, and that does need to be one tab level down. So I'll just go through very briefly what we have. So the GL window will contain all of the GL specific stuff for each window that we create. We'll have an ID, we'll have a pointer to the X11 window itself, and we'll also have a GLX context for each window, much like we did on Windows. And we'll also make sure that we can get our display connection and the screen ID. We're also going to look for a couple different things as well. So we're going to look for a FB config, so a frame buffer config, and I'll get onto those in a moment. We're going to look for some X visual info, which will, again, as it says here, it will determine certain factors about how the window works. We'll also get the GLX major version and minor version, and we'll also get the major and minor and patch versions for GL itself. But since we're not going to be really needing those as much, we're just going to comment those out for now. And we also have a pointer to the active window so that we know what window we're dealing with. And we also have a bool to check if we're using vsync or not. In terms of private things that we're going to have, the only one we're already having here is create context, because that will be much the same as the Windows class. It will just want to create a context for the given window, as you would imagine. But then we have our list of public functions, and they will be as follows. So we'll have a get visual info, create, destroy window, set active window, release active window, is using vsync, set use vsync, initialize, finalize, and swap buffers, and resizing the viewport. And to make sure that you can construct and destruct a window, we are going to create the constructors and destructors. But as of the current implementation, they do not do anything. And that is pretty much the entirety of this class done. So we can now move in to creating the source file. So underneath the Linux folder, we're going to go and create the GL Manager X11.c++ file. Again, we're going to want to include the GL Manager X11.h, and we're going to want to check if we're on Linux as well, just in case anything tries to compile this file. Then we're going to want to include from our display manager, and specifically we're going to want to include from display manager X11, because we are going to want some of the stuff from the X11 display manager here. And we're going to want our OS as well. Now, as you came to expect from the GL Manager windows as well, we are going to need to create some of our own definitions for some function pointers, and they are as follows. So the first one is a type def for creating the context attributes. So this normally takes, that should be a space there. This will give us a GLX context, and it will want a display, the frame buffer config, a context that already exists, a boolean for a value, and a integer which will contain all of the attributes that want to be set. And we also have our swap interval as well. And for the most part, our actual enums that we need here are actually contained within the GLX file header instead, so we don't need to define as many things. Underneath this swap interval, we are going to then hit a couple of enters, and then we are going to paste our context creation. And in fact, this here should probably also, this should probably go here as well. Make that change now. Simply because it's a function pointer, we're going to be loading it a bunch of times. If we have more than one window, we need to load it more than once. Kind of doesn't really make sense that we would load it again. So I would say if not Victoria, like so. So here it will return the address of the function pointer using what we want, which is this value passed in. And you do need to typecast these to unsigned bytes. So effectively unsigned cars, UN8s, but they do want them in this form rather than as a string itself, simply because of the way that the proc address function works. Next up, we have the context attributes, much the same as our Windows ones. We want a 4.6 context, so we request one. We want a forward compatible, and this should also be a core profile, but I'm not quite sure if I can set that yet. So we have left that as is, and we pass it off as null there. Then we call to our loaded function to obtain a context. So as you'll notice here, we do request the frame buffer config, but we pass null when it comes to loading the GLX context itself. You don't actually need a prior context to create one using the context attributes function in GLX, which is a difference to how it works in Windows, where you do need to create a context to apply these context attributes for whatever reason. So here that is simplified somewhat. And then we just pass the context attributes in as is. Immediately after we've obtained the context, we're going to call to the X11 server to sync the display. This is so that any potential delays or inaccuracies when we're rendering aren't occurred, because we have immediately, now that we have obtained our context, this means that hypothetically we could start writing to the display. So before we do anything that could involve writing to the display, we immediately call to have it synced. And that happens even before we check if the context exists. But if it does exist, then we apply it to the window. Because we are passing an AND here, rather than just passing a copy of the struct, it allows us to modify those values like so. And then we just do a relatively simple call to glx make current to get the display, get the window from the window that we've passed in. We then get the context as well, pass all of those through. And if it can't make current, then we say we can't create. And otherwise, we load the swap interval ext as well, which we will get on to loading in a moment. And then we return OK from the function. Next up is the get visual info function. So this function is only really used once when we're containing our initial visual info, but it is required by the X11 server a little bit earlier, which we will get onto in a moment. And it is a relatively lengthy function, so I'll do my best to explain it, and I'll paste it in here. So the first thing I will say is that this is not directly all my work. A lot of this is more or less following what this link here from the Chronos wiki actually has for creating an OpenGL 3.0 context for GLX. and I've taken it from there and applied it here. A lot of the stuff that I've actually done has also come from another GitHub page that I will link in the description. This is a very, very good page that taught me effectively how to use X11 with OpenGL for the context creation here. And it's helped me immensely, so I will let you guys go and see that. But anyway, I will explain through the functions. The first thing that we always do is we check if a visual info already exists. You only ever need one per like OS or per instance of the engine. So if there's more than one visual info, then we try not to obtain it. But we also have a bunch of attributes that we want to apply, and these are shown as follows. So the first one is that it is X11 renderable. We set that to true. We also set the drawable type to a window, the render type to an RGBA. So that's the number of color values. The visual type to true color. We have the RGBA sizes. They are all set to 8 bits in size, as is normal for a uint 8. So this will be 0 to 255 per pixel. We also set the depth size here to be 24 bits, and we set the stencil size to also be 8 bits. And we also enable double buffering as well. So the way GLX works is that when it tries to obtain frame buffer configs, rather than giving you one from the specification that you've given, it will give you a whole bunch of frame buffer configs and ask you to effectively loop through all of them and find the best possible config for each. So the things that we have to pass here is, for this function here, we return a pointer to the first frame buffer config, and we also need to pass in the frame buffer count using our display, the screen ID, and our attributes that we want to apply. And therefore, this will be an array of frame buffer configs rather than simply being one frame buffer config. And if it doesn't exist, then we will say that we can get one, and then we return null. Then we set up another whole bunch of values. So we set up our best, worst, the best sample count, and the worst sample count. So this is, we are basing this on how many samples we can get for each frame buffer. And the highest sample count is the one that we are going to use. So here we loop through every single frame buffer that we got from the list. And per that, we will get a visual info, which is obtained from the frame buffer config, passing in display, and the current frame buffer config. If the frame buffer config exists, then we want to get the number of sample buffers and the number of samples obtained as their attributes. Then we want to check a couple of values. So if the best FB config is less than 0, so it is still -1, then we want to set the best FB config to the current one and set the best sample count to the number of samples we got. Or alternatively, if there is a number of sample buffers and the number of samples is better than the current sample count, then we set the best sample count to equal the number of samples. And alternatively, if there are no sample buffers and that all the number of samples is less than the worst sample count or the worst sampler count, then we set the worst FB config to whatever this is. And at the end of that, the worst number of samples is whatever we got here, because you don't want to have alternatively less ones. It could potentially be changed so that the worst sampler count is set to whatever this is, but for now we are keeping it as is. And then we call to X3 to free the visual info, because it is an allocated pointer rather than just being a standalone pointer from somewhere else in memory. It is allocated. And once that's looped over so many times, we'll then get to we'll have some values here. So we'll have the best frame buffer, the worst frame buffer config, the best and the worst sampler count. And because these are all saved off already, we don't actually need these values here. They just tell us some other things when we're looping through. And the only value we want is the best frame buffer config. So we set the GLXSB config, the best frame buffer config, to whichever one that we found within the array. And then we free all the other frame buffer configs because they are no longer needed. Then we get the visual info from the frame buffer config. So we call to GLX get visual from frame buffer config. And if that doesn't exist, then we're going to have to do some certain things. Here I've closed the display. We should probably do something else that causes the system to panic. But for now, that's all we're doing. And then we return null pointer. And alternatively, if the screen ID is not equal to the visual info screen, then we are going to close the display and return null pointer again. Then we're going to set a couple of things in our code. So we're going to set our frame buffer config to whatever the best frame buffer config was. I'm also going to set our visual info to whatever the visual that we got was. And hence all of the information in here can then be set because we now have things like our visual info and our frame buffer config for our context to use. Those were some pretty long functions. So as a reward, we get to have some really short ones. Here will be the creation and destruction of a X11 window or a GLX window. So here, all we do is we call to new GL window to allocate a new window. We set its ID. We set the window to whatever was passed in. Then we want to create a context for the window. If that doesn't happen, then we return -1. Then the active window is assigned to be the new window, and then we return the active window's ID. Otherwise, for destroying a window, if there is no active window, no need to destroy. And if the active window's ID is the same as the ID passed in, then we want to make the current context. We want to make the current context null, so there is no context passed in. Then we destroy the context that we had, so the GLX context. We then delete the active window and set it to null pointer. So make sure that all the memory is out of the way. Then there is the setting and releasing the active window. So we don't have a get active window here because I don't actually think it's as needed a function currently. But here we set the active window based on its ID, which currently doesn't do anything because the GL window, as you can see, isn't returning from an array. So if the ID is anything more than 1, it's not going to do anything. Or in fact, this function doesn't actually need to do anything. It just wants to check if the window ID is invalid, in which case it will return. So here all it does is it just retrieves the window and then passes in the window, the GLX context, and so on and so forth, because that is all the setting the active window does around here. And then releasing the active window is effectively the same as destroying the window. Next up is our vsync functions. They're relatively simple. So if we're using vsync, is set to whatever the value was passed in is. If we can't find the swap interval and the value is false, then we can't disable vsync as the extension glx-ext swap control is not present. Otherwise, we try to obtain a drawable, and if that drawable exists, then we call to the swap interval. And this will normally take the display, the drawable, and the value. So if the value is true, then we will use vsync, and if it is false, we will set 0, which means that we will not use vsync. We're getting near the end of the file, so we'll just go and explain the next few functions. So in initialize, we have we need to get the display and the screen ID. So we pass ds here, which statically casts display manager X11 get singleton to a display manager X11. Because we are on X11, this is safe because there is no way that this would be like a display manager Windows and therefore loading the wrong set of function pointers. And of course, if that cast failed in any way, then we'll return error null. Then we just want to get the display and the screen ID. And again, this really will never happen because the GL Manager X11 will be owned by the Display Manager class. And currently these functions don't exist. Okay, so I'll update these in a moment. Then we have finalize, and all this does is it releases the active window, frees the visual info, and sets it to null. Then we have swap buffers, and you can imagine very similar to Windows. All it will do is it want to check if there's an active window, and if that's the case, it will call to glx swap buffers on the display and the X11 window of the active window. And here, if the active window is null or if the height is 0, then we return. And otherwise, you call to GL viewport to resize the entirety of the window, 0, 0 being the top left corner, to the width and height of the entire window. Now that's pretty much everything within this file explained. And just before we go and do all the applications of this elsewhere, we do actually need to go and update our Display Manager X11 to be having these functions. So just under here, we're going to create a display pointer get display const return display. Then we're going to have a screen get screen const. We're going to return the screen. And then we want an int get screen ID const return screen ID. And that is all of those functions dealt with. They're, again, ridiculously simple, quick getter functions. Apparently, I forgot that we needed within this class. And there we go. That's all of the GL Manager X11 setup. So with this all done and dusted, we can now move on to actually implementing all of this into our code. And as you can imagine, this is going to spend a lot of time in the display manager because there shouldn't really be any of this that occurs within the OS because this will always be specific to X11. So within our display manager X11, we're going to go here, we're going to go down and we're going to create GL Manager X11, GL Manager X11. And by default, it's going to be set to null pointer. Now, you are going to be silly and you're going to forget that you don't actually have this included anywhere yet. So you're going to scroll up and you're going to go here and you're going to hit include GL Manager X11 and include it like so. Now within the source file, we're going to change up some stuff specifically around here with our create window function. Now, as you'll remember from the application layer that we did for Linux, a lot of this stuff that we set up here, we didn't ever end up actually using. And you can tell by the fact that a lot of it is using the simple window function. Now, this is going to change because as I was initially reconstructing, I realized at one point that I had only ever written this to be using GLX. And since we were creating this before we were creating GLX, it meant that the entirety of the process of writing this had to basically be done on the spot. With all of that said, we are going to have to change quite a lot of things here because using simple windows doesn't actually allow you to use, it doesn't allow you to use the rendering that you want to use when using GLX contexts with X11 on its own. So with that said, what we're going to do here is we're going to first off make a little bit of space. And what we're going to do is we are going to get a struct of X visual info, visual, and initially it's going to be set to null pointer. Now, if there is a GL Manager X11, which by this point in the code there should be, we will add in the bit where we initialize GL Manager X11, then the visual is going to be equal to the GL Manager X11 get visual info. As you'll remember, that is the reason why we made that function public, because otherwise we wouldn't be able to access this function because it would be private. And of course, if the visual cannot be found, then we are going to have to return a couple things. So the first thing is if it's null, and if it is null, then we're going to return -1. Now the event masks we can actually leave alone for now, but there is something that we need to add to our value masks. So here we're going to call int value masks, and we're going to set a couple of values here. So we're going to do CW back pixel, CW, oh, that should be an OR, CW color map, or CW border pixel, and CW event mask, like so. So this gives us a border, a color map, an event mask, and the back pixels to render to. And the exit window attributes so far is all fine. Border pixel, the background pixel. We also need to set the window attributes.override redirect to true. We also want to set the window attributes.colormap to equal an X create color map of display, root window from the display and screen ID, the visual part of the X visual info, and you want to pass alloc none here. And once that's done, we can actually tear out a lot of this X create simple window, or at least we don't tear out. You can leave the first part, but the bits that we will need to add are from here. So instead of passing 1, we're going to pass 0. From there, we're going to pass the visual depth. We're going to pass input, output. We're going to pass the visual of the visual. And this needs to be X create window. I forgot. There we go. And that'll prevent any errors. Then you want to pass your value masks in. And then you're going to want the address of your window attributes struct. And from there, it will create you a window with all of that data applied. Next up is the last little step that we need to do for our GL Manager. So again, we're going to check if GL Manager X11 exists. And we're going to want to, well, create our GL window. So we're going to pass a uint8 id equals GL Manager X11 create window. And we pass in the address .win. So you pass a pointer to our window struct. And if the ID that we get back is equivalent to -1, then we're going to delete the GL Manager X11. We're going to print an error to the console. Then we're going to return error can't create. And otherwise, we're going to change this here so that instead of setting the ID to 0, we just set it to whatever this ID returns. And then we set the window to equal the win data, and we return the window ID. And that is our create window function now all updated and actually using X create window, as you can see. So then we need to go to our destroy window function and do much of the same here. So we are going to go here, and the first thing we want to do is we want to check if GL Manager X11 still exists. And if so, then we call GL Manager X11 to destroy the window, passing in the ID. Then we're going to call to X free color map, passing the display, the window, .window attributes .color map. Because as with a lot of things in X11, it's allocated, so you want to make sure that it's freed internally from X11 as well as from the rest of our memory. Within the process events function as well, we need to add another case. So here we go to case expose, and this is the method that happens whenever the window is changed and therefore needs to be redrawn to. So here we're going to get an X window attribute struct, again called window attributes. Then we're going to X get the window attributes from display, window.win, and passing the address of the window attributes so that it is filled out appropriately. And then if we actually got that, then we want to call if GL Manager X11, again double checking, because later down the line, when we start adding things such as Vulkan, we're going to want its own checks for whenever it's trying to do its thing. And here we're going to call GL Manager X11 resize viewport to the size applied within the window attributes .width window attributes .height. Is worth noting that the X window attributes here is different to the X set window attributes that we have in our window data. And simply that this is the currently active one, whereas that one is more of a cached version. And of course, in our swap buffers function as well, we're going to need to do the same kind of thing. So if GL Manager X11, we're going to call to it to swap buffers. And in finalize, if the GL Manager exists, then we're going to call to it to destroy the window. Or sorry, to GL Manager X11 finalize. And then we're going to have to do a very similar wacky thing that we did with loading GLAD. So here we're going to call to GL Manager X11. There's a new GL Manager X11. Then we're going to create a window. And then immediately afterwards, we're going to call to GL Manager X11 initialize, which will set error ERR to equal whatever this was, and then error fail condition message errors not equal to OK, error messages, error. And that will give us the desired result. And one last change, we need to delete the GL manager once we're done with it and set it to null pointer. There is one more thing that we need to do, and this is simply because of how these functions are written. So here within GL Manager X11, the first thing that we're going to do is we're going to call to glad load GL. So if glad load GL, we are going to want to display an error very similar to the one in our GL Manager windows. And this simply occurs, so the reason this is here is because of the current setup that we have, we don't have a rendering server yet. And since there is approximately one glad function that we're calling, or actually a handful, so we have GL clear color and GL clear, and we're also calling in GL Manager X11 when we are resizing the viewport to GL viewport. We still need to load the glad functions, but in the future, this will be placed in the rendering server because that is a place where we want to start loading any OpenGL specific stuff rather than loading it here within our GL Manager. But anyway, all rambling out of the way, we are going to hit Ctrl-Shift-B to compile. We should see that we don't get any errors. And hopefully speaking, if we hit F5, we should be able to run. Oh dear. Well, that's a bit of a problem, but it is ultimately fixable. So what we're going to do for this fix is we're going to go to our GL Manager X11. We're going to uncomment it as simply having its definition there. And we're going to go right to the bottom here, and we're going to write it here. So what it's going to have to do is on construction, we are going to do all of this rather than doing it there. And this is for the reason that because glad needs to load after the window, but we immediately, because we want to immediately have things like the display and the screen ID, because we're trying to create a window before those things are loaded into memory or they are loaded properly, it causes segmentation fault because it's trying to load a null pointer and the null pointer is undefined behavior. So we'll build again. I'll have to build all of the binaries once more, but hopefully we can hit F5 and everything should run as intended. Okay, well, as it turns out, it was me being a bit of an idiot. Here, we're meant to pass win data instead of window. Because window at the moment would be set to null, so it would start trying to modify memory outside of the actual readable zone. So it would be trying to give you a null pointer there, which for some reason passed, even though you're trying to pass the address of a null struct here. It doesn't really make sense why that wouldn't throw an error there, but whatever. So hopefully now building and running again, having reverted a couple of those changes, we should see that now we get the desired result. The window is now blank. And it might look very unremarkable. It's a dark background. There's nothing going on. But if you remember from the Windows video, all we are doing here is we are giving it a clear color and clearing all of that color out. So this is a pretty big landmark. This now means that we have context creation existing on both Windows and Linux. And therefore, the next episode, we will be able to start doing things with GL code. We'll actually start writing things for OpenGL rather than writing setup, and we can get onto the bits that everyone has been waiting to see. Anyway, I do hope you enjoyed this video, and I'll catch you in the next one. A bye.